Hey everybody, welcome back to another edition in geometry. Mr. Anderson here with you. We're still in section 8.1. This is the second part of that. In the last section 8.1b, we talked about a little bit about the geometric mean and simplifying radicals. So today we're going to go a little bit further with the geometric mean in a specific situation where we're dealing with right triangles. So our objectives are going to be identify similar right triangles, and then we're going to solve problems using the geometric mean in right triangles. Okay, so it's dealing with right triangles today. All right, so take a look at this. Here's the scenario that we're dealing with today with the geometric mean. Is we have a right triangle, and if you notice here, I've got ACB. Okay, so look at this big triangle here, ACB. It's a right triangle because you have the right angle mark there. Inside of that triangle, what we've done is we've drawn an altitude from the 90-degree angle straight down, which creates another 90-degree angle. And so what this is saying here is, in this situation, you have the original ACB triangle, and then since this makes a 90-degree angle here, now you have an ADC triangle, this one kind of a medium-sized one, and now you have CDB, a small one here. And what this is saying is all three of those triangles are similar. Okay, so remember, similar means, again, all the angles are equal, they're all congruent, but the sides are not congruent, but they're proportional. Okay, so the ratio of the sides are proportional to each other. All right, so here in this one here, the example says ACD. Here's the trick, is getting these in the right order when you say if they're similar or not. We're going to do this in the next example here to show you maybe a better way, because it gets kind of confusing with all this. But ACD, so ACD, well, that's ACD, here we go, it's a medium-sized one, is similar to ABC, and CBD is similar to ABC, and then they're similar to each other. Okay, so let's just do one. I think that'll be better. Okay, so here's our situation. We're going to try to determine how these are similar to each other. Okay, so we just talked about, in this situation, when you have a right triangle, you've drawn an altitude, these triangles are similar. So the big one that you started with, this little blue one, this medium-sized red one, are all similar. But how? In what order? Okay. Probably the best way to do this, I think the simplest is, let's just redraw each one of these triangles so that they match up. They're kind of in the same order, so to speak. You can do this any way you want to. I think I'm going to start with the little one maybe first, this blue one. And if you notice, okay, so this is 90-degree angle, so this is also 90. And you notice this is the short side that's attached to the 90. Here's a long side. So I'm going to draw this little one. I'm going to kind of draw like this. And that way, there's the 90. Okay, so if that's the 90, that's H, right? Let's label this H. Up the short side is E. And then F goes down the long side, so this would be F. Okay, so there's the little triangle, EHF. All right, let's look at the red one, kind of the medium-sized one. I'm going to draw that the same way, so it's going to be a little bit bigger. Something like that. Now this one's kind of easy because it's in this orientation already, right? So H is here at the 90. Up the short side is F. And down the long side is G. Okay, so there's that one all set up. And then lastly is the big one here. So I'm going to draw this even bigger, because this is the whole entire big one. Now this one we have to flip around a little bit. So now look at this big triangle here. Where's the 90 degrees? The 90 degrees is at F, right? So this 90 degrees on this triangle is F. If you go up the short side from F, the short side from F is what? E. And then down the long side from F, from 90 degrees, is G. Okay, so what I've done is I've taken this drawing and split it up into 3 different triangles where they're kind of in the same orientation. They're in the same order where the 90 degrees is in the same spot. The left side here, it's the short side on all of them, and underneath is the long side on all of them. Okay, so now I know which ones match up with which, and so it says write a similarity statement. Okay, so on this first one, I'm going to say triangle. I'm going to go EHF is similar to what? Triangle. If I went EHF, I'd just go FHG. And then on the third one, EFG. I just go in the same order. That's supposed to be a triangle, by the way. That's my similarity statement. So on this, you notice the hardest part is just kind of setting this all up. Once you've got all these triangles drawn, this is really pretty easy. Now, granted, you might be able to write this and figure this out directly from this drawing and not have to write these 3 triangles. If so, congratulations, that's great. To me, that's pretty hard, and so I would suggest writing these 3 triangles out like I did here. That would be my suggestion. Okay, next one. Now we're going to start talking about the geometric mean, okay, and in relation to this situation with the right triangles like we just talked about. So if you notice, here's this drawing here, ACB, the big triangle, and there's some things written in here. From A to C is little b, from C to B is little a, from A to D is little x, from D to B is little y, from C to D is little h, and then the whole A to B is C. Okay, so it's broken up. We've got these little letters signifying all the different distances here in this. Okay, I wanted to put this in here. Don't worry about this too much, but I just want to show you the background on why this works really quickly. And I didn't want to have to draw out all these triangles over and over again, so that's why I just put this in here. But look at this. Okay, so what they've done here in this drawing is they've done the same thing that we just did, just redrew all these triangles that are similar to each other in the same order. Their order is like where the 90 degrees is up on top like this, but they're all in the same angle. And so what they did was they said, let's look at doing a shorter leg over a longer leg. So that would be B over A, the shorter over the longer. Here's B over A. And then that's the same as X over H, which is the same as H over Y. If you notice on those 3 things that are all proportional there, look at what happens here in the circle. X over H equals H over Y. Remember what we talked about in 8.1a? The geometric mean is when you have the same thing that's on the bottom of one side of a proportion and the top of the other side. So this is going to be a geometric mean here. And then on the second part here, and so what this means here is this. Let me write this in below here. I think in the next slide I'm going to talk about it as well. But that means when you cross multiply these, h squared is going to equal xy. And then how do we find out what h is? Remember, take the square root. So h equals the square root of xy. So this is one little formula that we're going to use here in this situation to help us find distances. So if we know the distance of x and the distance of y, we can find out what h is by plugging it into this formula. Okay, look at the second one, hypotenuse over the short leg. So that's going to be c over b, and then b, hypotenuse over the short leg. Oh, there we go. C, here, sorry, I was looking at the wrong one. C over b, and b over x, and then a over h. So look what happens here. Oh, look in the circled one. C over b equals b over x. Once again, you've got a situation where there's a geometric mean. So again, you know, you'll go through the same steps here, but what does that mean? That means that we're going to have b squared equals x times c. So when you take the square root, b is the square root of x times c. Here's another little formula that we can use. So in this case, if we need to know what b is, we can find it if we know x, this little part, and the whole thing. And finally, it's the hypotenuse over the longer leg, so you got c over a, b over h, and a over 8, or a over y. And if you notice, the 2 outside ones here make a geometric mean. C over a equals a over y, and so guess what? A squared equals cy, take the square root, a is the square root of cy. Here's another little formula. So we've got three little formulas here to help us in this situation figure out what different distances are going to be. Okay, so let's go to the next slide and take a look at this. This is kind of what we just worked through. And so if you notice here, this top one, 8.2, theorem here just says h, and here's what I had just showed you, h equals the square root of xy. So if you want to find out what this is, just take, and you know these two, take the square root of that times that. X times y, take the square root, you know what h is. On 8.3, there's two different things here. If I can pick it out of all the stuff they got here. B, here's this one. B is the square root of x times c. So it's not x times y, but it's this short part times the whole thing. Okay, so that's how this has to work to find b. That side that's right next to b times the whole thing. And then the other one is a, and if you notice, a is the square root of yc, so a is the square root of what? The side that's closest to it, y, times the whole thing. So if you can kind of remember those three patterns, this is going to be pretty easy. Okay, so let's look through one here. Find c, d, and e. So we're going to find c, d, and e. I always like to start with e because that's the altitude, and that's that first one that we did. So it's the altitude, which was that first formula. So what that means is e is going to equal the square root of 6 times 24. If you can just remember that little pattern, very easy. Well, now here's where, you remember what we did last time, simplifying square roots? You could just multiply this out and get some big number and simplify it, or you could just simplify it kind of separately like we've done before. So this is going to be, I'm going to call that square root of 6, and I'm going to break 24 down into the square root of 6 and the square root of 4. Why would I do that? Well, I did that because if you notice, the square root of 6 will match up with this square root of 6. Hey, look, it's a date. And so together those make just 6. And what's the square root of 4? 2. So in the end, this equals 12. Sometimes you get lucky like this. It came out nice and even, what am I trying to say? Nice and even or easy, like 12. You could possibly also plug that into your calculator. You know, just do the square root of 6 times 24. You should get 12 there as well. All right. Oops. Oh, wait a minute. We weren't done there, were we? C, D. Let's do C next. Okay, so remember the formula there. C is going to equal the square root of the number closest to it, that's 24, times not the 6 over here, but the whole thing. And so this whole thing is 30. So in this case, I have to go 24 times 30. Okay, well, let's simplify that. Again, if you notice, think about this. We can break 24 down into what? 6 times 4. 30 could break down into 6 times 5. So let's simplify. 6 and 6, hey, it's a date. Okay, so together they get to go out of the house as 6. Square root of 4, that's just going to be 2. And then we got square root of 5 left over. And so when this is said and done, that's just 6 times 2 is 12. This would be 12 square root of 5. In this case, if you plug that into your calculator, you're not going to get 12 square root of 5. You're going to get some decimal. But it should be the same decimal that you get if you plug 12 square root of 5 in your calculator. You'd get that same decimal. The reason why we like to do this as much as we can is this is more precise. If you get a decimal, it's going to have to round somehow or another. So that's why we like to do this. All right, then lastly, E. Let's see, I'm going to do it up here. Or no, D, C, D, what have we not done? E, C, D. I'm going to do D up here. So, and then if you remember, D is the square root of the one closest to it, 6, times, again, the whole thing, 30. So let's do them separately. Square root of 6, 30 would split up into 6 times 5. Hey, it's a date, 6 and 6. So this would be 6 square root of 5. And again, it would be better to simplify it like this if you can. it's more precise than the decimal. Okay, so there you go. Let's see. I think we got one more here. That's this kind of thing, and then I think one more after this. So E, find E to the nearest tenth. Well, let's see here. Here's E out here. So we got to remember, what formula do we use for that one? We do the square root of what? Well, remember, the altitude was the square root of the two short pieces. Well, both of the legs out here, so E and F, are the square root of the side closest to it, 16, times the whole thing. So in this case, that's 16 plus 4 is 20. So we're going to go 16 times 20. And so, well, the square root of 16 is just 4, right? Square root of 20, we could break that up into the square root of 4 times the square root of 5. What's the square root of 4? 2. So really we got 4 times 2 times the square root of 5. 4 times 2 is 8. So this would be 8 square root of 5. Keep in mind, just remember, when you're dealing with square roots, anything that's underneath the radical can get multiplied together or split up. Anything that's outside, like the 4 and 2, once they got outside, we could multiply those back together. You just can't do like the 4 outside times the square root of 4. You have to write those separately. Or you can't do this 4 out here times the square root of 5. You can't make that square root of 20. It doesn't work that way. Underneath can multiply, outside can multiply, but you can't kind of cross that boundary. Okay, the only way you can cross it is if you get a date, and then you get to come outside. But notice, look at this, before we move on. Remember, they give us these, all these different things here. They said 8, 4, and 16. Remember what the formula was for this one? They give us the numbers here, but let's check to make sure it's okay. It said that was this one equals the square root of 4 times 16. What's the square root of 4? 2. What's the square root of 16? 4. Does 2 times 4 equal 8? Yes. Wow, that is so cool. Look at that. The numbers that they gave us worked, and we didn't even have to figure it out. But you notice it worked with that pattern that we were doing. Okay. All right, last one. Now this gets fun. Okay, really fun. Zach wants to order a banner that will hang over the side of his high school baseball stadium. That's a pretty good stadium there. Look at how high that is. And reach the ground. How tall will the banner have to be? So he wants to find a banner that's going to go all the way from up here all the way down. But here's kind of the setup of it. Here, Zach is. He's standing 5.75 feet off the ground. So that's his eye level, is straight to here. He's 10.5 feet away from the stands. And he's trying to figure out how tall this is going to be. Well, what we have to do is find out what x is. And then whatever x is, we just add 5.75 to it. That'll give us the whole thing. So this is basically just a big right triangle that we drew the altitude on, and you have another 90-degree angle there. So remember the pattern that we have to do here. So this is an altitude. So the way we're going to set this up is 10.5 equals the square root of 5.75 times x. Okay, because that was like the first one that we did, not for the legs. It was the formula for the altitude. Well, all we have to do is solve that little equation. We're done. This seemed a lot more tricky than that, but you go, well, that's not that bad. How do we undo the square root of something? You square it. So take this whole thing, square it. Take this and square it. The square root cancels the square. So what we have here is 5.75x. And then over here, I'm just going to go 2 times 10.5. So that's going to be 21 divided by 5.75. So 21 divided by 5.75 will give me, and we're going to round this to 2 decimal places. I'm going to call it 3.65. That's what that looks like. Now, obviously, if this is the case, if x is really 3.65, then, oh, you know what? Oh, you know what? I was thinking that didn't seem right. You know what happened here? I take a square this, and why did I write this little 2 over here on the left side? Write it on the right side, okay, Mr. Anderson, that's stupid. So 10.5 squared, that's why, that's stupid. Some of you may have caught that. Great, congratulations. I'm dealing with a little cold right now, so you know. So what this should be is 10.5 squared, not times 2. And so I'm going to just, you know what I'm going to do? I'm just going to redo it over here. So this is going to be 110.25 equals 5.75 x. That's much better. And divide by 5.75. Now we get an answer that makes sense. So it's 110.25 divided by 5.75. So that's going to be approximately 19.17. That makes more sense. This is a good lesson, though, that even for me, a math teacher, sometimes I get going too fast or don't pay attention close enough. Just make sure, you know, when you get an answer, like that's what happened here. I didn't realize until I got that answer. I said, boy, that doesn't seem right. If that's 5.75, it's only going to be 3.65 feet higher. That doesn't seem right. And then I noticed, oh, look what I did. I did 2 times 10.5 instead of squaring it. So good lesson there. Just always think, does this answer make sense? To finish this out, though, to find the whole height, x is not the whole height. That's only from here down to here. We have to add it. So we have to add 19.17 plus 5.75. And then that will give us the total answer there, which would be approximately, I'm going to do the squiggly equal side, approximately 24.9 feet. Okay, so there you go, 24.9 feet. All right, well, appreciate you being here. That's geometric mean and some right triangles. Thanks for being here. We'll see you next time in section 8.2. Take it easy. Bye.